Hello, everyone, and welcome to another Into the Terminal. Today, we're going to be talking about Linux Logical Volume Management, or LVM.
Indeed, we are.
So, Nate, I know that you've put together a captivating critical path for us. You ready to jump into the terminal?
Is it captivating? I guess we'll see.
I am captivated by it.
Well, really, you're all captive, right? Because you're stuck with it. So, all right. So we'll talk a little more about what LVM and volume groups and whatnot are when we get into the deeper dive. But we're going to start with just some basics. How do I make a volume group, and how do I put a logical volume in it? So let's go ahead and get started with that. So first of all, I've got some additional block devices that I've added to this machine. Volume groups get laid down on top of disks, whether they're virtual, physical, whatever. You need a block device to lay it down on top of. In this case, they're virtual disks that I've added to this machine. So we're going to first create a physical volume. PV create. And what this does is it preps the block device to receive a volume group and logical volumes on top of it, right? There's stages here that we have to deal with. So we're going to go dev loop 0, because like I said, these are virtual things that I've added to this machine.
And
okay, what this does, go ahead.
Nate, in logical volume parlance, it puts down a volume group descriptor area.
There you go.
VGD.
Right. Okay, so now that we have the PV or physical volume created, we can do, there's another command called PV display, which will just tell you what physical volumes or PVs are connected to this system. You can see this is the only one we've got. So now we're going to add a new volume group on top of that physical volume. So we're going to do VG create. You're going to notice a very similar theme to how all these commands are named. All right, so VG create, we're going to give it a name. We're going to call it VG0 because it's whatever, simple name. And we're just going to point it at dev 0, which is that physical volume that we just made. Okay, and now that just said, okay, this PV is part of this volume group. It's really, all we're really doing at this point is putting down like metadata, tying these things together. Now, if we do a VG display, only if you type out the AY at the end of VG display, we can see we now have a a volume group on this system, and it gives us an idea of how much space there is available in the volume group. Now, if there were logical volumes deployed in here, it would also tell you what's allocated, but in this case, it's empty. So it tells us there's 511 extents, physical extents is what that means. And it tells us about how big it is. It says that it's just under 2 gigabytes, right? And that makes sense because the disks that I made, I have 3 2-gigabyte disks, and we're going to use the other ones in future examples. All right, so let me refresh the screen here so that we can get this clean. Now, what we're going to do is an LV create. Now, what this does is it puts a logical volume, which is the place where we can actually put a file system inside of the volume group, okay? So LV create, and then we have to give it a size. Now, there's a couple ways you can give it a size. You can specify this based on how many megabytes, gigabytes, kilobytes, whatever you want this thing to be, or you can specify the extents, the number of extents you want it to be. So in this case, the lowercase l says this number of extents. We know there were 511 extents available, so we're going to make it 511 extents. We're going to fill the whole thing. And we're going to give it a name with the -n flag. We're just going to call it LV0. You might give this a name that's a little more descriptive. For example, when I'm provisioning, for example, my home lab, I named the logical volumes based on what the data I intend to store in them are, right? So I have one that's called like VG store, VM store for the virtual machines that I run, right? Just an example. So you can call it just about anything. I'm sure there's limits on the characters, but things you can usually name files after you can change, or you can set these names to. All right, then we're going to tell it what volume group to put that logical volume in. Now, there's extra commands you can put in here that specify things like the size of extents and yada, yada, but we're going pretty basic with this. All right, and now we actually have a logical volume inside of our volume group. If I do an LV display, remember what I said, PV display, VG display, LV display. There's a theme here. LV display is going to show us the logical volumes that are inside of our, or that are attached to the system. And in this case, we've got VG0 with an LV0. It even tells you what path would interact with that device at dev VG0 LV0. And the structure that that LVM lays out. Okay, now the last thing we can do is let's go ahead and make a file system in here. We're going to make it an XFS file system. Now, again, there are extra commands we could be throwing in here, but we're just going to go basic here. And we're going to say make an XFS file system on dev VG0 LV0. And there we go. It makes us a file system. So now you can see that we're treating the logical volume like it's a disk, right? You could have written that directly to a block device or to a partition on a block device. In this case, the logical volume, you might almost think of it as a partition, right? Like this is the device which you're going to be putting your file system and then your storage in. And there's our demo. We have any comments there, Scott?
Just one. Hey, Nate, can you try VG display -- JSON and your volume group name?
I can try.
No,
Error during parsing. No,
didn't work.
Was this a comment that came through in chat?
Yeah, maybe VG's -- JSON VG0, but I don't know. This is what happens when we go off script. It all of a sudden we're just flummoxing around trying things out.
Nope, no idea. It doesn't know what you're talking about.
We'll just have to get a.
Go look at the man page, Scott.
Oh well, Shantanu did look at the man page, and it's not in there. But I thought it may have been one of those undocumented options that sometimes sneaks through. So,
lead me astray here, Scott. I had a perfectly designed demo, and now it's ruined.
Well, this is what happens when Manager Scott shows up to things. I want to talk to you about your TPS reports too while we're here. So after we make the Swizzly graphic play, we're going to get more into LVM, and we're going to be talking about things like how to extend a volume group and file system within it. We're also going to look at moving things around. Maybe you're obsoleting a device, or one is too small and you just need to migrate something to a new one, or you're moving from one storage array to another, and so you need to migrate your data. So we'll be looking at some of those situations as well. Don't forget to like and subscribe, and we will see you after the Swizzly graphic.
Swizzly.
That's right. I was recently asked by one of my coworkers, what do you mean by Swizzly graphic? And it turns out that if you're a deferred viewer, you actually don't see it, or the time that it takes to play it. And so for you, it looks really weird because we're like, hey, join us after the break. And then we immediately come back and look all weird. So we'll talk about how
I just saw it on the live stream. It's like the live stream didn't catch up quickly enough. I don't know. I can't explain it.
Yeah. Well,
you had like a millisecond of the graphic, and that was it.
All right. So, Nate, we're going to talk about mounting that volume group or the logical volume that you just created. Before we do that, like, do you want to spend some time talking about the meta device that we've created in DevMapper and how that looks?
Yeah, or honestly, just what problem are we solving with LVMs and volume groups and whatnot, right? I think that's a good level setting exercise here, right? Traditionally, you would lay a file system right on top of a block device, and a lot of operating systems still treat file systems that way or storage that way, right? Windows, for example, when you're laying down, I guess that you can get more creative, right? There are ways to get this done, but generally you've got a physical disk, you lay down a file system, and that's where your stuff goes. And it's really important, of course, to then back up your data, because if that underlying block device starts to fail, the only real options you have is to replace the block device and move your data to a new one, right? LVM gives us the ability to, one, you can span volume groups across several block devices, which is really handy in a virtual world because you've got all these virtual disks. Maybe you just need to expand a VM. You're putting in a new disk underneath it, and you just expand the volume group onto the new disk, right? I did that a ton in my systems administration days, but you can do the same thing with physical disks too. Now, Personally, I think that having several physical disks in a volume group, it can sometimes be dangerous. Just because if you're not paying attention and you miss the fact that one of those disks dies, it could corrupt the whole file system, and that's not good, right? But if you are paying attention and you notice that a disk is failing, LVM gives you the ability to replace it. You can move all those extents over to a new physical volume, and that's exactly what we're going to show later on in today's demos.
Well, and in my production systems, I almost always use some type of RAID as my underlying block device.
Right.
Um, and then I use LVM on top of it so I can carve that large pile of space into smaller pieces for usage around, for VAR or home or whatever.
Right.
So I push all of the resiliency stuff to a RAID, and then I don't have to worry about the resiliency stuff with LVM directly.
In my time as a systems administrator, I've seen people think that the volume group is like a RAID. And it kind of is, but it's like a RAID 0, right? And everybody knows
Well,
what RAID 0 can get you.
there's actually like a whole bunch of options in LVM to make it kind of function like not just a RAID 0 where you can stripe across multiple devices or try to fling
Right.
your data across multiple devices, but there's also mirroring that can be set up in it. So it actually duplicates your data across multiple devices. But the reality is like, why not use a thing that is dedicated for that task? Like RAID,
Yeah.
even
Yeah. I mean,
software.
there's even software RAID that you can run inside of Linux that even if you're on a machine that doesn't have a physical RAID controller, you can RAID across several but they have to be the same size device, of course, but you can I think it's MD Atom. Yeah. Unless there's a newer technology now that I'm not thinking of. But yeah, why not do that instead of depending on LVM to save you?
Right. And MDADM is the correct utility for working with software RAID.
Yeah.
It also uses the dev mapper subsystem. So
Yeah.
like the thing that's actually doing all the meta device management does both meta device management for software RAID and meta device management for volume grouping.
Right. Right. All right. So yeah, we can mount that logical volume if we want to show people that in fact we did get a file system here. So you remember we made LV0 inside of VG0. Now, Scott, you just talked about that dev mapper or not file system, but structure, right? So inside of dev mapper, you're going to see VG0-LV0. As you created more logical volumes, there'd be a new VG0-LV1 or 2 or 3 or whatever. And if you make more volume groups, they show up as the name of that volume group. Or you can just go to good old school ls dev VG0, right? Sorry, there's too many things that start with the letter V inside of dev. Dev VG0 will just have devices inside of there for each logical volume. Now, I don't know if there's a good reason to use one or the other. I, I generally use dev mapper when I was mounting these things in production, but you can mount either, right? I don't know if there's something where if that were to change, dev mapper is smoother. I don't know, but anyway, just kind of backing into a hole here. But we're gonna mount the dev VG0 LV0, and we'll just mount it in /mount because I don't know if that's a better place to do this. Mount, we're gonna do dev VG0 LV0.
It helps if you spell mount right.
Oh yeah, mount. Maybe you don't know. Maybe I have a system alias for mount. You don't know.
I do not know.
Inside of /mnt, right? And now if we do like a df-h, you're going to see, look, there's my dev mapper. Oh, it just mapped that anyway, instead of going to the dev VG0 LV0. So you don't have a choice. Doesn't matter which one you do. It just goes to the dev mapper anyway.
Yeah, when it
Uh,
displays, it uses the dev mapper path. But
yeah.
you can use interchangeably either the dev mapper path or dev volume group name, logical volume name in all your commands that you use. It'll figure it out.
And let's just go ahead and put like a file in there. Super valuable file, empty file. It's the file name that matters, not the contents, right?
It appears
So
to be a super easy file.
yeah, it's super businessy. I could even put that in there if you want. But anyway, so there we go. We have it mounted, right? And you can see that I didn't have to know or care that it was a logical volume as long as I knew what device path it was in. You just mount it like any other disk. All right. So what if, my super awesome test file there was so big that it filled up the whole disk and now we need more space, right? This is one of the things that I think is really helpful and probably one of the most common things that I've seen LVM used for to kind of save the day on a Linux system. And that is this flexibility that it gives you to expand and even contract disks. Now, yes, we've had lots of conversations about how XFS can't be contracted, but you can certainly, when you add space to a volume group or a logical volume, if that logical volume is then removed or whatever, or you added too much space, you can always take that back out again, right? It's just the file system underneath that will sometimes give you trouble there. But we're going to go ahead and we're going to take my volume group that I just created and we're going to add another disk to it. So let's do a VG extend. See what I mean about these simple command names. VG0, because we got to tell it what volume group we want to change, and we're just going to add another physical volume to it. And like I said, we've got a couple of these loop devices. You see that there's loop 0, 1, and 2. We're going to add loop 2 because loop 0. Sorry, we're going to add loop 1 because loop 0 is already in there. And then what it's going to do is it's going to simply take the volume group and say, oh, this additional, oh, look, I forgot to make a PV on there. And it did it for me. That's handy. I didn't know it would do that.
Yeah. So remember a while ago we were doing file system stuff and we were trying to break it, and it would like not overwrite an existing file system without warning
Yeah.
you. Yeah,
Man, what
well,
the
we've
heck?
done the same thing with logical volume stuff. It's like, what are all the rakes someone steps on and smashes themselves in the face with? Let's stop doing those things.
But all those broken noses I've gotten over the years feel like they're completely in vain now.
Well,
Well,
we're
anyway,
new people.
luckily it just worked. I didn't have to make the PV. Normally the procedure would be you make a PV on that disk and then you add it to the volume group, but it just did it for you, so that's handy. I guess I don't know what would happen if there was, hopefully it would check if there was already a file system there or something.
If there
That could
is
be
a
awkward.
volume group descriptor area and it belongs to another volume group, it will error out and not let you add it to this one.
Okay. All right, so VG display now again on VG0, and we should see that there is an additional 511 extents because that's about the size of the additional space that we added, right? So you can see here, we've allocated 511. That's what I did in the critical path. And now there's an additional 511. That's that new disk that I added. Now, if the new disk you added is even slightly different in size from the first disk you added, that the number of physical extents that are available is going to be different, right? This is just because I literally made these exactly the same size. They're all exactly the same block devices.
And that's actually one of the other cool things about logical volume management is you can use physical volumes that are of different sizes. And the logical volume manager won't care. It'll just chop them up into the allocatable PE size that you see here in this output. That's the physical extent size. And so if it's 2 gig or 20 gig or 500 meg, it'll chop it up into those extents and throw it into your storage pool.
Right.
Nate, real quick, we did get, thanks to Rick Green and Shantanu, a revised how do we get this in JSON.
Yeah.
So if you do a VGS -- report format space JSON on your volume group name.
What did I typo? Anything?
I think it looks good.
Looks good. There you go. For those
Boom.
of you who love JSON. What was the point of this?
Shantanu was like, if only these commands would output in JSON. I was like, challenge accepted.
But why? Who likes JSON? Apparently
mean,
Shantanu.
Ansible loves JSON. Python people love JSON. So like, there's a lot of places.
I guess.
Sounds popular.
I guess. Okay.
Right, sorry, didn't mean to interrupt your demo.
All right. So we added an additional PV, which it created for us, which was very handy, to our volume group. Now, and we showed that there's additional space there. And there's a couple things you can do with that space. You can extend a logical volume. So, if LV0 was full and I just wanted to make it bigger, I could extend LV0 into some of those free extents, all of them, some of them, whatever I want to do. Or I can make a new logical volume. So say it's actually that I need another partition for something, but I forgot to do it the day that I provisioned this machine. The security compliance people came back and said, home really needs to be its own partition or something, right? What I can do is I can add that disk. I can add it to the volume group like we just did, or I can make a new volume group if I really wanted to. You can have several volume groups on the same system. And then you can make another logical volume. And what I'm going to do is I'm going to make an additional logical volume inside of this volume group. So we're just going to do the LV create again. We're going to do -L 511 because that was how many extents we had available. We're going to give it a new name of LV1 because LV0 was the other one that we did. And we're going to tell it to do it inside of VG0. Now, obviously, if I had instead extended the LV0, then the file system on LV0 would also have to be extended into the new space. And there's additional commands to do that, which I neglected to look up before the show, which is why I'm not extending XFS instead. Okay, so now if we do another LV display, we should have 2 logical volumes. I think if I just do VG0, yeah, there we go. It'll give us 2 logical volumes. We've got good old LV0 that we had before and LV1 that's here, now that we've added the additional space. All right. Any questions we need to answer before I move on? I was going to go into how do we move that data if we wanted to?
So as though by magic, one of our viewers, which is
XFS
Tech
Pro.
Pros
Yep.
YT, was teeing you up for this, and they asked, what would happen if I removed a physical volume and now my data is gone? And my original response was, well, you would have had to work really hard to do this. Because if you just try to remove a physical volume, it will error and say, I can't do that because there's data on this thing.
Right.
And the recommended process would be to use PV move, which Nate is about to show us.
Right. Right. So I could try to do a PV remove just to show you, but do you think it'll explode?
No, it should error because it's in use. That would be my expectation.
What was it? Dev loop 1 was the additional one that I added? Right. So what PV remove does is it just goes to the block device and says that metadata that's on there, take it away. Right. And then, of course, the rest of the tools will realize that thing is no longer part of the volume group. Now, if I do this, yeah, okay. PV dev loop 1 is used by VG0. Please use VG reduce first, right? So this would be, so in this case, I've already created a logical volume that uses these extents. So I have to delete the logical volume, or I'd have to shrink them all to the point where they're small enough to fit on one physical volume. And then I can do VG reduce to take away those 511 extents. And then, only then, should PV remove allow me to remove this disk, right? Because it knows that what's going to happen here is I'm going to cause file system damage.
And I love that it's so against the grain to actually do it this way. That's like, if you really want to, not only do you have to specify -- force, you use -- force twice in a row. I'm going to force you to
really force. I'm going to really force this. That is nice. Because why would you do that? Why would you forcibly remove the PV if it knows there's data? If it knows you're going to lose data.
Yeah, so I have seen a similar-ish situation, which
Right.
is somebody removes the disk, like physically or in the hardware or the storage array that
Oh,
you're
right.
attached to. Like those guys disconnect it from your machine and now you've lost it.
Yes.
So that's a slightly different situation because there you're not actually working with the logical volume stuff, you're working with hardware stuff. And in that situation, if they disconnect the device from your machine, the device data is still there, right? Assuming they didn't destroy it or something silly. But if they just disconnected it, you should be able to connect it back again. And the volume group descriptor area that's on the physical volume that tells it what volume group it belongs to and how big it is and what physical extents are in use, all that metadata is still intact. So now
Right.
that it's been connected back with your machine, you could try rebooting, because then all that stuff gets reinitialized and it'll scan the disks and see the disk has been added back and fix it.
Yeah.
You might be able to do something like a VG import something,
Well,
but that
there's
yeah.
a bunch of sort of troubleshooting tools that we're not covering today that let you do things like activate and deactivate specific logical volumes and volume groups, that scan for physical volumes, scan for volume groups. You could probably do some concoction of those things to bring that volume back in if you absolutely can't reboot. But rebooting would probably also do it because all that stuff should get done at boot time, right? But personally, I don't like to reboot a machine unless I'm sure it's going to come back. And if I've just plugged the disk back in, I'm not sure it's going to come back. I would probably try all the other options before I try to reboot.
Yeah. The other thing is, if that happens and somebody like yanks a disk out of the volume group and disconnects it from your box, all of a sudden you'll start getting a lot of error messages in your log
Oh yeah.
complaining that like disk UUID whatever is no longer accessible, and like anytime you interact with that volume group, it will be very sad.
Yeah, I've had this happen. We had the snapshot chain on a VM get messed up. So the VM was running just fine, and then all of a sudden the snapshot chain was broken, and there was disks like literally data from the disks just vanished because the snapshot chain got broken. I don't know how it happened. I forget exactly what the circumstances were, but it took me some time working with Red Hat support to try to figure out like how the heck do I resolve this thing. And sure enough, we got it back. We got the data back. Pretty cool. Pretty cool.
Awesome.
So, all right. Let's see what was next on my list. Oh, we were going to add another disk and then migrate to it. So let's assume that loop one is a bad disk. We've gotten, I don't know, smart errors, or maybe it's just that loop one is small and we'd like to replace it with a larger one, right? There is a way to gracefully do that, and that's what we're going to do next. So first of all, I'm going to add. There's another loop two that we added, so we're going to do a VG extend to add loop two. Oh wait, I'll do this right this time. PV create on dev loop two, because the pedantic side of my brain says you're supposed to do this, even if it did it for me. So we're going to make that PV this time. Then we're going to VG extend VG0 and add in dev loop 2. Now, we've done this like 3 times at this point in this show. This shouldn't be a surprise to you. But what we can do now is, now that we have, if we do a VG display, we should see that there's another 511 available PEs, right? Which means we have free space within the volume group. So what we can do now is we can use a tool called PV move that will take all of the metadata / extents, whatever, from one volume or one physical volume and move it to a new physical volume. And what that should do is it'll clear up any data that lives on the old PV, so that disk is then clear to be removed from the volume group, and it'll move it to the new PV, right? So now imagine the new PV was bigger. There may be some other things to do to try to, well, you'd have to like extend LVs and VGs and whatnot after you're done. That would be like cleanup tasks you'd do after you finished. What we're going to do is PV move, and all you have to do is point it to the source PV and the destination PV, right? So dev.
So if you just do the source PV, it'll then use all the remaining PVs to try and migrate your data.
Oh, okay. Okay, so
Well,
it'll just say, all right, so loop 1 is the one I want to get rid of. It'll just say wherever you can put it inside of the volume group, move it. Is that what you're saying? Okay.
Yep.
You can also specify specifically disk by disk, and that's what I had initially tested for the demo. So, okay, well, cool. We'll do it that way.
But doing it where you specify a target disk, will make sure that the extents from loop 1 go to a specific spot. If you do it this way,
Right.
they may end up, if there was free extents on loop 0, you'll find some there. You may find some on loop 2. Like, it just kind of like squishes stuff wherever it can find it.
And in a lot of cases, that might be just fine. right? But in some cases, maybe it's not. In cases where you're absolutely like, I want everything on the old PV on the new PV, then you can specify the source and the destination. But I can understand where you might not care. You might just care that you move it to somewhere that's available, right? So,
Well, and
okay,
honestly, with like changes to how we're doing storage now with stuff like NVMe drives, where it's solid state memory as opposed to spinning rust, like all of a sudden, a lot of the things we used to really care about don't really matter anymore.
right, right. Excuse me. Okay, and now I should be able to. Oh no, I got to do a VG reduce first, I think. Yeah, sorry. So now we got to do. Remember earlier we got that error. It says you have to do a VG reduce before you can do the PV remove. So VG reduce. And we're gonna go VG 0, and you tell it.
You want
What's that?
VG reduce, not CG reduce, right?
Oh well, you never know. Maybe that's some
Or
other
there's
awesome thing that you don't know about.
secret Nate command line aliases that I don't know anything
Yeah.
about.
Now, I think you can tell this to reduce it by a certain number of extents, but you can also point it to the PV that you want to remove. Right? So we're going to say, basically, take all the extents that maybe are allocated on loop 1 and make sure that it's clear and remove it from the volume group. Or I should say clear it from the volume group, right? Okay, and then now see already it says loop 1 is removed from the volume group. If we do a VG display or a PV display, so if I do a PV display, it should tell me that loop 1 is basically unallocated. Yeah, right there. Loop 1 is a new physical volume of 2 gigabytes, whereas loop 2 is in VG0 and loop 0 is in VG0, right? And this one says it's not in a VG. Now, if I also wanted to go so far as to say this thing is no longer a PV at all, that's when you would use the PV remove. Oop. PV remove on dev loop 1, right? And what that does is it just clears that metadata off. It says you're no longer a PV. So now if I did a PV display, we should only have loop 0 and loop 1 or loop 2. There you go. All right, so that's how you might move data from one PV to another without actually disrupting the system. Now, you might remember, we'll use DF, I think, instead. I still have that file system mounted, right? So that volume group is not only still active, that logical volume is not only still active, the data is still accessible. Everything was up and online while I was doing that. Now, is that advised? I don't know. If it's a high utilization disk, maybe not. But yeah, I did it all live. So there we go.
Yeah, so there was a little bit of
There's my
commentary in
super
chat
awesome file.
from Shantanu saying that you can use PV move with a logical volume name as well.
Okay.
And my point to him in chat was you could do it that way, but the scenario that we were displaying is like, I want to replace this disk. I want to get rid of this disk. And that's why we were PV moving off of it. If
Right.
you use a volume group, that's a situation where you're worried that your volume or your logical volume is using storage off of multiple different disks. And for some reason, that's not what you wanted to do. And so by using the logical volume name and the physical volume name, you can take all those disparate extents that are in use across and like concentrate them somewhere. Which historically, I don't think we really cared about, because if you could access multiple physical devices at the same time to get data, that was better. It's kind of like RAID-ish.
Right.
But again, a lot of the changes to storage, all of a sudden we don't care about things like where things live or whether it's on the same drive or not, because we're not having to spin that platter around to get to that sector to retrieve it from disk.
Right. Right. All right. So the only other thing that we could cover is there's metadata about these logical volumes that's stored inside of Etsy. And I'm not going to go into an exhaustive tour of this stuff here. But if you go to Etsy LVM, you can see there's actually an lvm.conf, which allows you to configure some of the defaults and whatnot for how LVM behaves on your system. There's also this backup directory. And inside of the backup directory, you're going to find literal backups of the metadata for your volume group. Now, this isn't data. This is the layout of the volume group. So if I did a cat on backup slash VG0, you'll see, and I don't know, is that JSON? It might be JSON. But you see it's got all of the disk data, the size data, the extent data, so that if I did have some sort of corruption where the logical volume metadata had been somehow broken, which is exactly the way that we had fixed my disk problem with that snapshot chain problem, which is the whole reason I know this is even here. You can use this to replace that metadata if it's been corrupted in some way, right? So handy stuff to know about. Maybe this is something you can add to your backup routine, just so you're sure that that you've got it. And I think that's all my demos for today. Any other questions we need to answer?
No, I think that's about it. I did want to call out Fatim. They mentioned that having systems in the cloud and using cloud storage is like another kind of shift in storage paradigm where like we don't necessarily know or care what devices it's stored on. So doing things like
Right.
PV movement and other stuff um, may not be as useful as it once was.
Yeah.
But
Well, cloud is similar to virtual when it comes to that, I think. Although there are, right, there's storage. I mean, there's like block store, but not block store. What's the word I'm looking for? Bucket storage that absolutely doesn't care because like the whole underlying subsystem is so different and abstracted from you. But yeah, cloud storage I would call is very similar to like virtual disks, like you'd see in a VM environment too.
yeah, and Tech Pros YT also mentioned that they had some problems with their disk devices reordering after reboots. And he pointed out that if you look at something like PV display, and here we'll
Hmm.
bring Nate's terminal back up here. If you look at something like PV display, you'll see that in every physical volume, there's a UUID that's put in the metadata. And
Hmm.
Nate, I bet if you do a LV display, there's one in there too. And if you do a VG display, there's one in there too.
Yeah.
So in the Etsy stuff, there's actually like an arrangement of these physical volumes are part of this volume group, and this volume group has these logical volumes on it, and it's all tracked by UUID. And so when you boot
Yeah.
the machine first time, or when you boot the machine, I should say, it actually does a scan and then pulls out this UUID identifier and then figures out like how to reassemble your logical volume configuration based off of it.
Right. And the logical volume names and the volume group names are not dynamic. Those things are stored inside of that metadata, right? So those aren't going to change at boot time. If you had a dozen volume groups on here, it's not like they are named in the way that they're ordered. You could call them, whatever you want, and they will be the same every time you boot. So there's even less chance that you're going to lose disks after, I should say, you lose data because of disk order, the order the disks came online or were scanned, because it's not referencing the disks. The logical volumes are referencing those by UUID, which does not change, and the VG and LV names are static; they don't change.
Shantanu asks the best GUI tool to deal with LVM. I actually really like Web Console.
I don't think I've ever used a GUI to make an LVM other than the RHEL install media.
One of our coworkers, who you may have seen from the RHEL 10 beta series, Matt Mycini, he's like super experienced. And I remember when I first joined the team, he told me that he would never again use all the command line utilities for doing LVM stuff, that he was just going to use Cockpit and Web Console from now on. And I was like,
Yeah,
really?
I'm not saying you shouldn't. I'm just saying I don't think I've ever used it. I haven't tried it yet.
Well, let me tell you the killer app of why he said that. So when we were going through and like resizing our file system, you basically let it use all of the disk space for the new
Yeah.
disk. But what if you only wanted a certain amount and you put in like grow it by 50 megs?
Yep.
Well, there we actually have to do math because we can only grow a logical volume by its extent size. which in your
You
situation was 4 megs. And so if you
so
say you
you
want a certain amount, it'll complain about not having the right amount of
oh right.
extent.
Okay.
But in Web Console, you pick it up, you say add space, and then there's a slider. And you just like adjust the slider to roughly about the amount that you want. And it does all the math for you. And so you don't have to do any of those
But
things anymore.
Scott, real sysadmins can do that math in their head. It doesn't matter.
Oh, oh,
No, I get it. I get it. I mean, it's an argument we have time and time again in this industry. It's yes, the graybeards can do it in their head, but is it really worth their time? What value are they bringing in doing the math in their head? Except that at 2 a.m. when they don't have a GUI, they can probably do it in their head, right?
right. Well,
But for the rest of the time, use the slider.
in reality, I think that they would, like, I get that error and like, oh, let me just round up and try it again. And that's how I
Yeah,
do that.
and I mean, it does. It's not like it stops you. You can. I think you can still allocate it. You're just losing a little bit of disk space. I think Scott's been interrupted. Okay, but yeah, you can still create it at whatever size you want. I think it just you're not being as efficient as you could be if you're doing it that way.
Cool. So I
All
think,
right, so
oh,
go ahead.
Vincent, my colleague says using Web Console is cheating. I mean, if it causes you to win, is it really cheating? And is
Yeah, you know, I've heard this phrase, and like ideologically, I'm opposed to it, but it's true. If you're not cheating, you're not playing. Right? Like if you're not cheating within the rules, if you don't understand the rules to the point where you can let things get by, right? Then you're not playing.
well, I would argue that it's not cheating if it's in the rules. It's just doing things differently.
Yeah, I guess that's true. I guess that's true. Anyway, I spent a long time agreeing that GUIs are for the weak, but to be honest, look, whatever gets the job done, right? Like there's no detriment, there's no long-term detriment to having used the GUI to make your LV. And all you're really going to notice is that you didn't have to spend the mental power to do the math in your head.
All right. So I think that runs us off the end of comments today. So don't forget to like and subscribe. And then Nate, what were we doing next week? I think it was disk elevators.
We talked about disk elevators. We also talked about that planning guide thing that we were talking about. I don't think that's next week though, is it?
I can't remember. We'll do one of those too next week, though.
There will be something cool next week, I promise.
Oh, you're right. I remember the planning guide thing. That's like the bane of all sysadmin's existence is writing things down, and yet that's the thing that saves you. And so we're going
Yes.
to talk to them about like what do you do about that?
Right. Right. But we'll figure out how we're going to plan the planning plan episode. And we'll get back to you.
So join us next week when we do another Into the Terminal. Maybe a topic we just talked about. Who knows? And we'll see you next time. Thanks, everybody.
Everybody have a great one.